Very good evening, Shiva. How are you? Okay, let's just wait for some time, like 2 minutes. Okay, then we're going to start with the class. Very good evening, Lakshmi. How are you, Lakshmi? Okay, then, so let's continue with the class. I guess everyone will join now. So, yes, first of all, wishing you very good evening, everyone. Okay, let's just start with the class. It's going to be our fifth session, basically. Okay, so let me just quickly give you a brief. In the previous class, we discussed about the tolerant test. What is the tolerant test? If I'm using silver ammonical nitrate solution, so that become a tolerant test. Okay, what was the use there? That if you're having any kind of aldehyde and if you're using a toluene reagent, okay, toluene reagent, so then what is going to happen in this case? That there's a simple acid formation take place. Okay, so this is the all for the previous class. So in today's class, which topic we are going to cover? That the test part, like this different tests like Fehling test, benedict test, like this. Okay, so let's just start with the very first topic of the class. It is going to be the Fehling test. Okay, so like some part you already covered in the previous classes if you remember. So what is the Fehling test? So let me just write properly what is Fehling test, then I will let you know like how to use. Same like first of all, who is going to participate, right? Who? So aldehyde. Okay, the substrate is going to be the aldehyde. Only aldehyde is going to participate, and please be noted only aliphatic. The Fehling test is never ever given positive by the aromatic aldehyde. Only that is aliphatic is going to participate. Okay then. So the next point that if we are talking about who and then how, like how means what we are end up there. So in this case, the reagent we are going to use. So basically that we have to divide the Fehling solution into the two part, that is Fehling solution A and a Fehling solution B. So we are using, it's a kind of mixture of Fehling solution A, okay, or a Fehling solution B. I will let you know like what is this and the Fehling solution B there. Okay, so what is this solution A and what is this solution B? We will discuss. Wait, okay? Let me just first finish the topic that what is going to happen there. So that if you are having some kind of aldehyde, so aldehyde at the end up into the acid there. Why? Because obviously we are discussing about the oxidation part. It means at the end, very good evening, sir. Okay, so at the end we are just add up with the that acid part there. Okay, so this is the simple framework there. But now what does this Fehling solution and Fehling solution be? Okay, so although it's not that much important here, only the reaction part is important, but still, okay, what is Fehling A and Fehling B? It's really important for the practical point of view, okay? It can be a Viva question for you. So let's just start. That is what is Fehling solution A. Anyone, do you know already about the Fehling solution A or Fehling solution B? Anyone? Is copper sulfate and a sodium potassium tartrate and NaOH there. Okay, so very good. So in this case we are having that Fehling solution A. Okay, so in the Fehling solution A, what we are using, sorry, so what is the Fehling solution A we are using? That is a copper sulfate solution. Okay, copper sulfate solution. And how about the Fehling solution B? So what is the Fehling solution B? It's a sodium potassium tartrate. Everyone, I hope you know the structure of the tartrate. What is tartrate? So it's a CH3. Oh, sorry. It's a COH is there. You know, meso compounds, so tartrate, meso tartaric one. So this is a tartrate kind of structure, tartaric acid. So in this case, you have to replace one hydrogen with the potassium, okay, or one hydrogen with the sodium there. As the name becomes sodium potassium tartrate. Okay, this is how you can remember if let's suppose you are having a problem with the structure. So it's a Fehling solution B, sodium potassium tartrate. Tartaric acid become tartrate there. Okay, and then in the presence of some base that you can use NaOH there. How about the keys, like how to deal with this? So this is not the important part here. Like basically what is happening there, that you will be having a copper, you know, that the copper present in plus 2 oxidation state. So actually this OH form a kind of bond with the copper. Okay, like OH being like a ligand. So let me give you like how the complex look like. So in this case you will be having a copper, but still it's not important. Only what is important, what is falling solution in, what is falling solution B, that's enough. Okay, so oxygen oxygen there, and then it's combined with CH and CH, and CH is there. So this is a kind of complex that actually this is how the structure look like, but we used to be like, okay, is what copper sulfate, and then B is what, that is a sodium potassium tartrate. Again, it's not important, just for your understanding point I'm explaining this, but it's not important for the yellow one. Okay, so let's continue that how the reaction look like, or how to deal with the reaction there. So in this case, who's going to react? Simply copper 2 positive. It means copper 2 positive is being like oxidizing agent here. Then like what about the general reaction? If I have to write the general reaction there. So the general reaction, if we are discussing, so then how about the general reaction, that you will be having some CHO, okay, only aldehyde and only aliphatic aldehyde, B noted. I'm repeating again and again, B noted. So it's a aldehyde part, and then that is a copper there, copper 2 positive. Okay, so same like the AZ, you know, that AZ ammonical silver nitrate solution, same thing we are end up. So this thing is going to convert into the acid, that okay, and this copper is present in Cu2 positive. How it is, this is how the complex look like, and in this case if you are observing the charge on a copper, it's become 2 positive. So it's a copper 2 positive, this is general reaction, and then copper is going to convert in the that copper 2 oxide. Okay, like how to confirm the test, the red color ppt. Okay, for this one we are having a red brown color ppt. Brick, sometime brick color can be there, red is brown, you know, the brick color. So the same here, copper oxide, red color appear, so it means it's confirmed, okay, that aliphatic aldehyde is present there. And one more, that OH, that you know, we are using that NaOH there, so it's O negative. Oh, I'm sorry, it's how to be acid. Okay, so this is how that the taste test look like simply. Okay, copper, that's it. You already done? Okay, very good, Shiva. Then maybe you know the test properly. Okay. So I know that the test is only understood when we have to done that test in a laboratory. Okay. Theory just like okay, but yeah, it's good point for you. So anyway, let's just talk about further, and please write a note that what is the note here. That note is very simple. So how about the note here, that we noted the aliphatic one is not going to react. So I am removing my video because so that we can wait. Okay, it's working. So look at this. That in this case, what is the note here? That only aliphatic aldehyde give test positive. Okay, not the aromatic. Only aliphatic one give the test positive here. Okay, so this is really very much important part here. Okay, so I guess this topic is clear for everyone. Okay, still any more problems? Please ask. Okay, although the test part we already covered in which chapter, I guess that salt analysis. I remember that part, right? Salt analysis part. Okay, then this is all for the Fehling test. Now let's just move further. That is the second test. So the next test is going to be the benedict test. Okay. Maybe these tests are not very much important here, but once we starting with the biochemistry again, it's going to be very much important that aldehyde, like alcohol, glucose, give Bandic test positive or negative. So test is really much important here. So it's a Bandic test. I guess Shiva, if you remember, you already asked me that, ma'am, how to do the practical kind of thing. Some question you asked there, right? Bandic one. So maybe you already know the Bandic test. So anyway, in this case again we're using a copper there, but this time we are using a citrate solution. So let me just write what is this. RHO, okay, RCHO, and then plus that is a copper citrate. It's going to be the citric acid. What is the structure? Not very much important for us. It's a 2 negative. And then we are using some kind of base as well. And in this case, the important is what? That our aldehyde is going to convert into the acid part here, that OH. Okay, next, in this case, copper is present in plus 2 oxidation state still, that we are getting a copper oxide. And what is the color this time? That is a brick red color. So the previous one is red brown. Although iron is what? Both color is almost similar. Okay, so when we are using the test, obviously we know that this is a benedict test. So the main point is what? Brick red, or the red color is the main point here. So brick red ppt again, and that OH is going to convert into water there. It's just normal reaction for a benedict test. Okay, this is all for the benedict test. Again, there is a note that in this case, like let me just back here, that same for this statement that both tests like behave same, that benedict test and the Fehling test both give the test positive only for the aliphatic, not the aromatic one. Okay, yeah, and I already searched this question earlier, Shiva. Okay, how much done till now? Dashika, right now we are discussing about the test. So the Fehling test is already done, and then benedict test. Okay, two tests covered already. And please, it's a request to you from the next class, join, okay, timely. Okay, okay, Dashika, so please be on our time. Okay, then, so let's continue further. The banding part is already clear. Now let me give a kind of chart for you, like the compound and which test give which positive. So like first of all, we are having some kind of compound. Okay, there's a three test right now. The first test is the Tolan test. Okay, the second test is the Fehling test. Okay, or the third test is the Benedict test. Okay, I hope it's visible. Okay, Benedict test simply. So in this case, the first we are going to use, that is aliphatic. Okay, we are using aliphatic aldehyde. Okay, and you will tell me like which is positive or which is negative. And the next one is going to be the aromatic aldehyde. Aliphatic aldehyde, aromatic aldehyde, and the third one is the aliphatic ketone. Okay, then aliphatic ketone, and one is acetyl. Acetyl. Okay, what is acetyl? If you remember in the previous class, I already told you that if you are having a CO bond and then two R group is connected like this, so it's a acetyl. Okay, let me quickly give you a brief that if the CO bond is there and then both site is occupied by the OR group, so it's going to be the acetyl. Acetyl and ketyl. Acetyl we are using when we are having aldehyde, or ketyl we are using when we are starting with the ketone. Not getting? Don't worry, I will explain. Wait. Okay. For example, if I'm having a ketone, okay, this is my ketone. And in this case, if I'm using ROH, okay, so 2 mole, let's say, what we are getting that R is there, okay, and then OR is connected here in OR. So in the very first, I'm having ketone. So ketone generate ketyl, okay, ketyl. And if let's suppose in the very first, I'm having aldehyde, okay, that is aldehyde. Same that ROH, if let's suppose I'm using, so in this case we are end up with that the same thing, but the name become it's a acetyl there. So aldehyde become acetyl or ketone become ketyl there. Okay, so let's just back again toward the table. So acetyl and ketyl. Okay, then so let's start that. Maybe you don't know about aliphatic that, what is it? Aliphatic ketone, wait. So it's aliphatic ketone, okay? And it's acetyl. Some more point left, but anyway, just answer this. First one, Tolan test positive for aliphatic aldehyde. So Dashika, of course, you have to revise. This is the only way. Okay. Just watch a one short video. Okay, and then try to solve the questions. Yes, please. Tolan test, aliphatic aldehyde. Positive, all are positive? Yes, all are the positive. Okay, so let's just back and see this. This is positive, positive, and positive. How about aromatic aldehyde? Tolan test. Just let me know the Tolan. Because Fehling and this bandit we just discuss. Access the model first. Yeah, you can go, Dishika. It will be better for you so that you can revise the basic topic. Okay, Deshika? Okay, Arul. So Ptolemy's, very good. So in this case, what is happening? That okay, it's a yes, and then Fehling, no and no, right? We just already discussed no and no. How about the aliphatic ketone? Yes, please. Okay, right now this is the irony. Okay, we are discussing some point, but wait for a while. We are going to discuss the exception part as well. Okay, then what all the thing required for the G registration? Okay, just check the guidelines that required when be like your 12th class registration. Okay, like you to go with the pursuing because right now you're in 12th. But if you're 12th pass, then you're requiring a percentage criteria. Okay, but like we can use the pursuing one and be like your Aadhaar card, basic detail like name and father name, like these things. That's it. I guess, and if let's suppose you want some kind of weightage, be like SCBC, so then you go to use that certificate. Okay, doctor's range. Yes, please. Aliphatic it on. No, okay. So in this case, all are the no, right? So this is no, and this is no as well. No, no, and no. Now, what does this acetal? Now, the second point starts. So acetal is going to give the test positive or not. So let's discuss about acetal. You know, basically what is happening there. Basically, that thing is going to oxidize. And you will let me know that is it a kind of possibility that I'm using a kind of oxidizing agent and it is going to convert into a kind of acid? Yes, please. What do you think? Is this step is feasible or not? PWBC that physically handicap. Okay, it means let's suppose you're you know some student is not able to write, so then you're requiring some kind of helper. So that's it. Okay, like normally handicap. Some like if you're having a problem in lag or that one. Okay. Yes, please. What do you think? If I'm having acetal or ketal, so it's going to give the test positive or not? No, obviously, because it's already packed. Okay, what is oxidation? Oxidation is a gain of oxygen, or what is oxidation? Oxidation is a loss of hydrogen. Here, hydrogen is not present, then how it is going to give the test positive, right? So be noted that if let's suppose I don't know, like, is this going, the test is positive or negative, but I know one thing that we are doing oxidation here. So in this case, no hydrogen, so it's no, and it's no as well. Okay, same you can go with the kettle. So let's just see the next slide. Okay, some more is there. Kettle. Now, how about the kettle there? So in the kettle, same. Okay, be noted like I'm writing now. TS means tolerance test. Okay, Fehling solution or that benedict test again. Kettle, no, no, and no. Okay, all three are the no. Okay, now it's really, 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 really very much important one. Okay, look at this. That is alpha hydroxyketone. It's assumption be noted that although ketone never ever give the Tolan test positive, but alpha hydroxyketone is the only ketone which give this test positive. Okay, don't worry, I will explain why it is going to give. Okay, why this is the exception. But just write a kind of table so that it will be helpful for you. Okay, so it's a alpha hydroxyketone, alpha hydroxyketone, and write a note, it should be terminal. We can't use the isolated one. Okay, I hope you know the meaning of isolated, but if you don't know, let me just give you a kind of brief. For example, if this is the CO group here, okay, and there is some R group and like alpha hydroxy, you know that at this position which group is connected, it's alpha one. So should we have to consider this? No, we can't consider this. Oh, sorry, CH3, let's say. Okay, so we can't consider this because it's isolated, it's not terminal. What is the meaning of terminal? When this is combined with some hydrogen, so it's a terminal. Terminal is the very much important point here. Okay, it's not inside, it's not isolated, it's how to be terminal. Okay, that's it. This is all for the case. Anyway, so it's a alpha hydroxy ketone there. So like Again, is this positive? This is positive. Fehling test, no. Okay, benedict test, no there. Oh, sorry. Alpha hydroxyketone both give the test positive. Okay, this is also positive, this is also positive. We are going to discuss about separately. Wait, okay. And next, carboxylic acid. Okay, so although carboxylic acid is already oxidized form, right? So, first of all, carboxylic acid. So, if we are discussing about the carboxylic acid, no, no, and no. Okay, all three are no. But again, there is an exception in the carboxylic acid, that formic acid. Okay, HCOH again give this test positive, positive, and positive. Why positive? Again, so it means in this case the 2 point is important, that why this is positive because it's a acid, and why this is positive because it's a ketone. Okay, so the two thing we are going to discuss. If you want to note it the table, it's important table, please note it down. Okay, question, so many time question asked from there. Let me just check any point I missed or not. And then hemiacetal, okay? Wait, there is a space, okay? I can write hemiacetal. Hemiacetal going to give the toluene test positive, okay? Again, this is important. Hemiacetal toluene only, Fehling no, okay? Benedict no. I have to highlight this, okay? Because I have to edit it separately. This is hemiacetal, okay? Wait, I will highlight everyone, every test. This is alpha hydroxyketone. Or this is carboxylic acid, and this is C, which is there. Okay, total four, like alpha hydroxy and hemiacetal and carboxylic in this. What is the exception here? That why the ketone give the test positive. Second one, that why acid give the test positive. Okay, now we are going to discuss about two important part here. Okay, let me just check the chat. Okay, I will. EVS means that wait, I will explain to you. This one. Okay, so what is the meaning of the EVS? That is economically weaker session. Okay, Lakshmi, you know there's some general category. Okay, so they are not having any kind of weightage. But if let's suppose your father income is less than 80,000 per year, okay, per annum, or like your family income is very less, so yeah, you are having a privilege that you will get that EVS certificate. Okay, so it's like a kind of certificate by the using of that you are getting a weightage in a general category. Okay, Lakshmi. So that's it. This is the meaning of EWS. No, 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 Arul. Okay. So I'm just explaining the thing only, just because so that we are able to finish the classes. Okay, Arul? Okay. So I hope this point is now clear. Now let's discuss about the exception here. Okay, if you want to note it again, okay, this is a table for you. Now let's start. That exception part start. First of all, that why the alpha hydroxyketone give the test positive. Okay, so let me explain this point to you. That okay, first of all, let's discuss about this question. This question is important. Question number one. Why does why does formic acid, since this is acid, but why the formic acid give Tolan test positive? Tolan and Fehling test. Okay, like Benedict one is not really very much important here. Mostly the Fehling and Tolan is the important here. So in this case, what is written? Why does the formic acid give Tolan and Fehling test positive? Okay, when other carboxylic acid not. When other carboxylic acid not. So it's an exception. Be noted. It's very important question. Okay, carboxylic acid. Okay then. So let's discuss about the point here. You know what is the problem? Why the acid is not giving the test positive? Let me just write R C O N O H is there. You know what is the issue? We discuss for the oxidation we are requiring at least one hydrogen, but this carbon has a zero hydrogen, right? Obviously it's not going to participate. But if let's suppose I'm using a formic acid there, then what is here? That Cu and OH. Like this is the common point in both the cases, but hey, here I'm having extra hydrogen. So yes, just because of the hydrogen present in this case, the COH give this test positive. Okay, HCH give this test positive because hydrogen is present here. Okay, so this is the extra point you have to note it. And let me just write the statement type. Okay, like why this give the test positive. Okay, so next slide, please. Okay, I hope you are done. So let me just write the statement why this give test positive. So the answer is what? Due to which this bond can be oxidized further. Sorry, okay, can be oxidized further, can be oxidized further in the presence of, in the presence of mild oxidizing agent. Okay, in the presence of mild oxidizing agent such as toluene. Okay, I will highlight like what is the meaning of this due to. Okay, so such as toluene or Fehling. Okay, so like due to which, that if let's suppose I have to rate this. Okay, due to just because of the extra hydrogen present there, so let me just write that the presence of aldehyde. You know, Toland test give the test positive only for the aldehyde there. So if you have to observe this portion, so it's become acid. But why we have to go with that? Why not I can do? Okay, why not I can do like this? So it's what? It's aldehyde, not a COH. Aldehyde we want, and yes, the aldehyde, one side we are having aldehyde. So due to the presence of aldehyde, wait, due to the presence of aldehyde, carbon bond there. So be noted that, like, first of all you have to write this and then due to the statement start. So this is the answer for the previous question. Okay, I hope everyone you are clear about this, the fact that why formic acid give the test positive. Okay, so that's it. This is all for the question. First question done, or first exception part done. Now let's talk about the exception number two, that why the alpha hydroxy ketone give the test positive. Okay, so again, let me just write the question kind of things that how the question asked. So question be like, why alpha hydroxy, why alpha hydroxy ketone give toluene test positive, or not toluene and Fehling test positive. Okay, like but other other ketone can't. So let's discuss about the answer again. So in this case, it's a tautomerism. It's really very much important topic. So what is the answer? Okay, first of all we're going to discuss about the answer, like how to write the answer in a paper, but like mechanism is also important. Let's write, we want alpha hydroxy ketone and terminal one be noted. Okay, so look at this terminal OH. Okay, terminal OH we're going to use, and then CUR is there like this. Okay, terminal OH. So in this case, this is a very famous kind of tautomerism. How it's tautomerized, I will explain this topic as well. So it's a tautomerism. Quickly recall ketone or tautomerism kind of thing. So in this case, ketone or tautomerism is going to take place, and just because of this, see how the thing going to suffer here. Okay, first of all, this is a ketone. Ketone will like I can't give the Fehling test positive or the Toland test positive. Okay, but molecule will like you are smart, I'm more smarter than you. So what is happening? That see the change. Actually now that after the tautomerization, it become acid. Oh sorry, aldehyde, and it's become alcohol. See the important part here. Okay, the change. That first of all, it's a terminal OH and now it's become a terminal aldehyde. And aldehyde, once it's generated, like the previous one, that one side of the formic acid is a aldehyde kind of thing. And hence, now it's going to give the Toland test and Fehling test, both test positive. Okay, like this is the first point, tautomerism there. But the next point, then how it is tautomerize? Because right now we know tried tautomerism, died tautomerism, like 1-3 tautomerism, 1-2 tautomerism. But what is this new kind of tautomerism? Let's discuss about this. Okay, mechanism. Again, please be noted, mechanism is not important for you. Okay, but it's important for the board exam. Like for the JEE main, it's not important. So let's discuss about the mechanism here. Let me just write R, CO, and H is there. okay, and then COR. So in this case, we are using OH, O negative, okay, base. So I hope you know that how the base come, OH here. So OH going to abstract this hydrogen simply. Okay, this bond break and this bond open up. Okay, OH attack on a hydrogen and this is how it's going to open. Next, that hydrogen and a OH and a double bond. Okay, this double bond and this bond open up, it's become O negative and a R. First of all, OH come attack on a hydrogen and this thing we are add up there. Okay, and like from this side what this is adding and like water molecule simply removing there. If you're observing, OH is going to combine with H positive and okay, water molecule simply release there. Okay, so that reversible reaction like this. First point. The second point, that in this case it is going to tautomerize. Okay, how it is going to tautomerize this part. Okay, I hope you know the ketone or tautomerism already. So in this case, oh I'm sorry, like you have to write the hydrogen if you miss. So in this case I am writing be like OH and OH and R is there. Okay, and hydrogen and hydrogen there. Simply that again it's tautomerize. If you don't know the tautomerism, I will explain. Wait, okay. So you will be having R, CO, CH3, and then that R, COH, and a double bond CH2 there. See this. If you are having this thing, so every time you are end up with a ketone kind of thing. So let's just back. Okay. So what is this? That is the double bond and this, and we are end up with the alcohol there, like this. Okay, so this is the point number one. We are end up with the alcohol. Oh, I'm sorry. Double bond. I missed the double bond. Double bond have to be there. The OH simply take the hydrogen from the water. Okay, where is the water? This is the water. Water will like take one hydrogen. So this is normally the hydrolysis step. Okay, the next step is what? Again water come. Okay, again water come. Let me just write the hydrogen be like this. Because you know what is the main agenda? We want the double bond here. So basically, first of all, H positive release, then again this H positive which has come with the like OH, and then again water molecule attack, and then okay, this is generated. Again, one more time water molecule come, attack here, this bond, okay, you know, there's a negative charge here. So what will be the next step? That H, CO negative, and a hydrogen, and a double bond, OH is there. Okay, R and hydrogen. This is the next step. Now, in this case, what will be the next? This here move here, this bond move here. Okay, so after this let's move to the next. Okay, we are having a space here. Okay, wait, please follow the arrows. Okay, now the next step is what? HCO. Okay, so we are getting now, look at this double bond here, and this bond open up, this is a OH and R and negative charge generated here. Okay, and this is a negative charge. Again, who's going to come? Water, definitely. Okay, so then again water come, and let's see what is the next step. Okay, I'm explaining this on the next slide. Wait, okay, so it's HO, CO, O, and R, negative charge, right? Again water come, so it's attack here, this bond open up, and we're getting an R. Okay, so this is the final answer. If you want to note it the step, these are the steps that first of all bees come, then water attack, then again it's restored, and then this, and then next one, this is the last step. Okay, this is how the alpha hydroxyketone is going to participate in the Tollern test or Fehling test. To exception, generally acid can't give the test positive, but here it give that formic acid. Generally the ketone can't give the test positive, but alpha hydroxydone and the terminal one. It's very very much important. Not every alpha hydroxy one, the terminal one is going to give the test positive. Now your turn, I guess. So much information. Okay. Now your turn. Any problem or any issue with the point that why it's the give the test positive. Okay. 5 bond where I will check. Okay. Maybe I missed some. 5 bond, 5 bond, where the 5 bond? Oh, I'm sorry. I'm really very sorry. Okay, just remove this. I guess again the 5 bond, right? So wait, remove. Okay, okay, Dashika, I'm sorry for this. Okay, this is how it's going to approach. Okay, so I hope it's clear now. Let's move further. This is all for the Fehling test and Tollin test and exception part as well. Now let's move further. Now let's talk about the next test, that is the Baeyer-Villiger reaction. Very important. Okay, very really much important here. Okay, so most of the time student has a phobia with this reaction as well. Okay, because this is the only reaction which is going to chase every rule. I will tell you why. It's a Baeyer-Villiger oxidation. Naming reaction, important reaction, and everything is important, like mechanism, then how it is going to work. So every point is important. And put star, it's really much important here. So what is Baeyer-Villiger oxidation basically? So let me just write properly what who's going to participate and how. So you can use aldehyde or ketone both. Because if you recall in the previous class, we discussed about the chemical property of aldehyde and ketone both. Okay, it means both is going to react here. So it's a aldehyde and ketone. So you can use aldehyde or ketone. And then the reagent is going to be the peroxy acid. Now the next point, what is peroxy acid? Right? Any acid you know? Okay, you be like, ma'am, benzoic acid we know, right? So not an issue. This is benzoic acid, right? Benzoic acid, everyone. Okay, so let me just write the benzoic acid be like this. Okay, so what is peroxy? You know the peroxy link is when you are having O kind of link. So just add one more OH in between. So it's become per benzoic acid. Okay, benzoic acid, insert oxygen there, and it's become per benzoic acid. It's become per benzoic acid. Similarly, acetic acid, when you have to fit one oxygen, it's become per acetic acid. Okay, so it means we are using some kind of per acid, peroxy acid. Okay, and then we are end up with the carboxylic acid. Okay, or sometime if wait, if we are using aldehyde, we are end up with the carboxylic acid. If I'm using ketone, we are going to end up with the esters. Okay, ketone ester, aldehyde acid. Okay, I know it's not very clear for you, just wait. I will explain each and every much important point about the Baeyer-Villiger oxidation. So let's just discuss about the Baeyer-Villiger oxidation further. Now first make this point very clear that what is the peroxy acid. Okay, we have to collect all the point, the reagent we are requiring, peroxy acid. So what is the meaning of peroxy acid? Although I already told you now, that is this is a O CO. So it's a what? Acetic acid. But now I'm inserting extra oxygen there. So it's become that is this is a oxylinkase, right? Everyone, it's become it's a oxylinkase simply. So it's my peroxylinkase, oxylinkase, okay? Like this. With our perbenzoic acid is a reagent of a product. No, it's a reagent. Dishika, wait, I will tell you that for example I'm starting with the aldehyde there, okay? Let's suppose this is aldehyde, and in this case this is a reagent, okay? Like it's just a reagent. It just a reagent. You know what is the problem? That peroxy linkage is not very good linkage. Why? Because oxygen has a minus minus charge here. It's not very good linkage. So in this case, this peroxy will like, I'm having extra oxygen. Aldehyde you want? Aldehyde will not an issue. Give me. So see this. In this case, this extra oxygen. Okay. In this case, this extra oxygen is given to the aldehyde. Wait. Okay. Look at this. This extra oxygen is given to the this. Okay. So RH will be like I'm already CO there. So hydrogen will be like I can fit your extra oxygen. See this how it's going to happen. Okay, aldehyde, just insert oxygen from the peroxy, and now see that this is already acid and one more already. Okay, so this is also forming a kind of acid. Okay, I hope this point is clear, like actually what is the meaning, or like what is the meaning of reagent here. Okay, Dishika, you can use anything per benzoic, any peroxy acid you can use. Okay, I just give some example, like this is a uh, acetic acid and the previous is the perbenzoic acid. Okay, Dishika. So anything you can use. Any peroxy. Like generally any peroxy you can use. Okay then, so let's discuss about this what we're discussing. Okay, so this is the reason. Like name you already know, so it's a peracetic acid. Peracetic acid, or the name is what it's actually what? I write the R there, so I can't use acetic acid, right? So it can be anything. Maybe it can be phenyl. R can be phenyl. Okay, this R can be CH3. R can be different group, right? So the name is what? Like we already covered, it's a perbenzoic acid and it's a per acetic acid. So first of all, Baeyer-Villiger oxidation, we are going to use a per acid. Per acid. Reason part, I hope clear for everyone. Second point. Okay, let's discuss with the second point here, that reaction, how the reaction going to take place. Everyone be noted. First of all, we are going to discuss about the general reaction, and then we are going to discuss about the important part, like how the reaction is going to proceed. Mechanism is not really important here, only insertion is important here, like where to insert the extra oxygen. Okay, so maybe right now it's seem very easy, but it's not very easy reaction actually. So you will be having some R, CO, and H, and then R, CO, any per oxy you can use, R or NH is there. Let me just highlight which oxygen is going to add this. This. It's important because sometimes you know how the question asks, be like we are using 18. Okay, so the possibility number one for this, what is the possibility number one? That maybe that R, CO and OH. Okay, so this is the product, or R, CO, O18H, which is the product. So it's been noted that the hydrogen next oxygen, that highlighted one, is going to add it. Okay, so which one is going to add it? This is going to add it. It's important. Yes, question asked from this. Okay, let me just erase this. So this is how the thing is going to add. Okay, the point number one. What is it? It's a carboxylic acid. Okay, one is this acid. This generated from this, and the second of this, like R, CO, and OH is there. So two acid. One is from the reagent and one is from the substrate there. Okay, next. What if I'm having a kind of ketone there? Okay, so sorted about the aldehyde, but how about the ketone there? Okay, this is a kind of ketone, and in this case again, I'm using any peroxy acid. Let me just use the simple one. OH, okay? So in this case, what is happening? That R, O, C, O, okay? R. Wait, wait, maybe it is be like what are you are doing? Wait. Okay, R. Noting something. That aldehyde is sorted, that you have to add the oxygen to add the hydrogen side. But what we are going to do now? Because my question be like, should I have to add the R dash side or should I have to add like OR side? So there is any rule? Yes, this is the important thing. Where to add in a ketone. Okay, so let's discuss about some symmetrical ketone and asymmetrical, unsymmetrical ketone as well. So let's just talk about the symmetrical ketone first of all. If I'm having a symmetrical ketone, then how it is going to work? Because the symmetry part is simple, easy. So symmetrical ketone. Let's see. Example, CH3, CO and CH3 there. It's a symmetrical one. Let's use this acid, okay? And again, highlighted point like this is going to add. So in this case, it's not like very difficult. You can add this side or that side. Okay, any side, both are the probable one. So as we discussed already, that aldehyde give acid, but in this case, what is it? Everyone, if you're observing, it's nothing. It's a simply the ester group. Okay, this is my ester group. Next point, that with the help of this per acid, one more acid is there. Now some of you be like, ma'am, but you said acid is not there. Be noted, ketone give ester. This acid is the reagent part, like the previous one. Okay, it's not the part of the substrate. So ketone, ester, okay, aldehyde, that only the acid. Next point, that what if I'm using this kind of ketone, for example, that is a CH2 and a CH3, okay, and a CO, or like CH3. So now question be like, that is the possibility number one, like this is the product, like let's say A, or the possibility number two, and be noted, it's not a pop-ups rule. Okay, because you know the problem with the student ketone and we'll apply the Pappus rule. Okay, that is the Carose acid. Which one? Actually, my chat and videos lagging. So which one? I use this Carose acid somewhere. Yeah, you are right. Per acid. Hmm. In this case, Carose acid. You said H2S. Yeah. Hmm. Wait. H2, SO5. So sulfur, double bond, OH, 1, 2, 3, 4, and 5. This is how the structure look like. You're right. Okay, Shiva? Per acid. No, 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 no. Okay. What is the meaning of the per acid? The carboxylic acid. Okay, Shiva. It's not a organic acid. It's an inorganic acid, Shiva. Okay. So we're going to use the organic part, not the inorganic part. Anyway, so but we're discussing. Yes, please. Anyone, do you know, like, should have to we have to go with the A or we have to go with the B? Okay, so listen. In order to understand that A is the correct answer, B is the correct answer, we are going to discuss about the mechanism. Mechanism for Baeyer-Villiger oxidation, like not important for the J, but it's really important for the paper. Okay, now next thing, mechanism. Try to understand the mechanism, and after mechanism the point will be very clear for you that we have to go with A or we have to go with B. Okay, so let's start with the mechanism of the Baeyer-Villiger oxidation. So let me just write the mechanism part for you. So how about the mechanism? Mm, okay, so in this case the step number one is the formation of tetrahedral intermediate. Okay, step number one is the formation of tetrahedral intermediate. Okay, so what is this? Let's try to understand the mechanism. We are using some kind of ketone. Okay, you can use aldehyde and ketone, like both have the same kind of mechanism. So it's RCO, and then acid we are using. Okay, so basically, do you know actually what's the like the main thing here? You know, you're using porous acid like this, O and ONH. So this H positive, still this is acid, H positive donor, right? So HP, like I'm H positive, and in this case oxygen has the lone pair, so oxygen is going to participate or attack on H positive ion. Okay, so next is that R, CO, OH, and a R dash is there. Okay, this is a step number one. Oh, sorry, double bond positive. This is the step number one. And then again, our per acid came into the picture. Okay, so it's a HO. I will highlight which point is going to attack. Okay, just wait for a while. It is a CH3. Okay, R we can use. Okay, because I am starting with the R. So there is some R is there. So this oxygen we have to highlight because this is going to add it. Okay, the yellow one. Next, that oxygen has a lone pair, attack here, and this is how the bond open up. Try to understand. First, this is the point. Next point, I guess it's visible. If it's not clear, wait, I will change the position. Okay, for the mechanism only, I have to remove my video. Okay, so that's what we're discussing. Okay, after this, next slide. Okay, I'm moving toward the next slide. Just let me know is this visible. Okay, I will check. Wait. It's visible, so I can use the part. Then I have to explain the next point here only. Next is that CO. Okay, it's a OH and then R and this O. Again, we can highlight this O, and then O, and then CO, and a CH3O. Sorry, R we are using, right? So R. Okay. So highlighted part, this OH. Okay, like the yellow wave from where we are starting already. Okay, so this is that tetrahedral intermediate for which we are talking here. Okay, so this is that tetrahedral intermediate. Actually, this is the final product. Okay, maybe you're not getting my point. So let me just explain how it's. Okay, so like this is a next step, but I'm sorry, my problem that I have to use the next step. RCOOH. Okay, focus on this step. And this is the O, and this is a H, and this is a CO, and CO and R is there. Okay, so I guess it's same. And then this hydrogen is removed because it's a positively charged, right? And then this is the tetrahedral intermediate. Okay, so this is that tetrahedral intermediate which we are talking here. TD intermediate, tetrahedral intermediate, the step name, formation of a tetrahedral intermediate. Okay, again I'm repeating quickly that oxygen has a lone pair attack here, then peroxy attack here, this bond open up, and this is how that OH positive generated and hydrogen molecule is going to leave there. Okay, so let me just write H positive. I am erasing this point. Okay, tetrahedral intermediate. Now the second step. Step one is clear, that is the formation of the intermediate. Now the second step is the rearrangement. Step number two, rearrangement. So what is the step number two? That is the rearrangement. This is famous for the concentrated step. Okay, so let me just write that is concerted step. You know the meaning of concerted step, that in the same step the thing is going to suffer. We are not using anything from outside. Rearrangement is a kind of concentrated step. For example, if let's suppose, just try to understand, if let's suppose the carbon has a positive charge, the hydrogen replaces, like change the position from one carbon to another carbon. I'm not using extra reagent from outside. So what is rearrangement, or the concerted step? That simply the thing is changing the position in the same molecule. Okay, it means single step reaction in short. So let's see how. R COH, okay, like this, and then O CO, and a R is there, and this is that R dash which already started, and this is the yellow oxygen, the main agenda. And in this case the rearrangement is going to take place. It's a rearrangement. Next step, that how the rearrangement is there. This oxygen has a lone pair H positive. This simply move. Sorry. So this OH move here. Then what is the next step? That R COH R dash, and this oxygen COH. Okay, now this is the step where we're dealing with the rearrangement, the positive one. Okay, it's important. So this move here, this R dash is going to switch the position, attacking here. Okay, attacking here. And then this move here, and this bond open up. Just try to understand this point only. Actually, what is happening? Let me just explain this step separately. You are having some R oxygen. Okay, then R dash and this oxygen there. So this R simply this R replace from there to there. You know how it's look like? That is R COH, and then there is a hole created like at the R position, and see that R connected here. It's be like you are simply connecting the R with respect to the oxygen. See the difference, that before the reaction that R combined with the carbon, but after the reaction the R combined with the oxygen. That R changed its position there. So same happening here. Okay, that R dash is simply replaced by the oxygen. Okay, so I hope the point is clear, like actually how the reaction is going to happen. So in this case means what I'm getting, that R, okay, double bond OH again, positively charged, and should I write OR dash? Okay, this thing already leave. Okay, this thing already leave, but we're getting that is R double bond O, okay, and a O and a R there. So the acid part is generated, the reason, because the only main agent of the reason to generate this yellow oxygen. Okay, I have to highlight this yellow oxygen. This is our yellow oxygen, which we are discussing, this yellow oxygen, like this. Again, bond open up, H positive is going to leave the molecule like this, and what we are end up at the end, that is this OR. Okay, sorted. Now, after the rearrangement, what is the point? Again, it's a mechanism if you want to note it. Formation of the tetrahedral intermediate, first step. This is this tetrahedral intermediate. Next step, that is the rearrangement there. So rearrangement part started here. It's a concentrated mechanism that is a single step reaction. It's a single step reaction. Be noted, everyone. Okay, now what is the first thing strike in everyone's mind or in my mind as well? Isn't it? It's a kind of rearrangement. Okay, it's a kind of rearrangement. So it means we are going to follow the migratory aptitude. So, ma'am, it means according to you or according to everyone, okay, now not visible. I will change, okay, Arul. I'm sorry. That's why I only ask you, like, is it visible or not? Wait, I guess this slide is okay. This slide is not visible, right? Okay, I will change, okay. Wait, Arul. I will change the position. Is it visible now, Arul? I guess it's visible. Let me just wait, separate this thing. Okay, I hope it's visible and clear. Okay, just quickly confirm, Arul. Okay then. So that's it. This is all for the that Baeyer-Villiger oxidation. So means I know one thing now that rearrangement is going to happen. So we have to follow that migratory aptitude one, that HPR rule, HAPR rule. So now we are going to discuss about the same thing, that is the migratory aptitude. And what was that migratory aptitude? If you remember, that we are going to follow hydrogen move first and then phenyl and then R, right? That HPR rule. But as I already told you, this is the only reaction who is going to change or which is going to change the every rule of the chemistry. This is the only reaction where we can't use this is a migratory aptitude. You know the real migratory aptitude here, that be noted, write the new one and it's important for you, okay? Oh, I'm sorry, my video. Okay, so let's discuss about the migratory aptitude now. So what is this? That you have to use hydrogen and then tertiary alkyl. So this time R first. And it's the only exception kind of thing. So that's why please write it properly. Secondary alkyl. And then that is a phenyl. Okay. And then primary alkyl. And then at the end that is the methyl. Okay, for example, how to use this order. Okay, for example, how to use this order. For example, if let's suppose I'm having a phenyl. Okay, this is the phenyl and this is a ketone. Okay, and this at CH3 group is connected, sorted. Now, according to the table, that which one has a maximum migratory aptitude here? Phenyl. You know, methyl is here. So this one has a maximum migratory aptitude. So it means that, do you know where I have to fit the extra oxygen there? This side. So this is how you to decide, and this is the Baeyer-Villiger oxidation. Here the only thing that migratory aptitude. Mechanism important? No, it's not important. Which is the important part here? Migratory aptitude is the only important. Okay, so listen my point. I know it's going to be a kind of difficult for you, ma'am, how to remember. Okay, so listen that let's recall our previous rule, HPR, Haber rule. Okay, still it will remain same like HPR. But what is the extra point? That R, the tertiary and the secondary, and then phenyl. So only R is, it means that only methyl we are going to use. Okay, so it's important. This is really, really very much important kind of migratory aptitude. Okay, now let's solve some questions. Okay, let's solve some question, and after that the point will be very much clear for you. For example, this is a question for you. Okay, and this is a question. Make this point very clear. And I'm going with the Baeyer-Villiger oxidation. BVO is the short form for this. Okay, BPO. Now there is some option for you, and migratory aptitude, Arul, that was going to rearrange. For example, Arul, let's just suppose, the carbocation, if you remember. If let's suppose this is a CH3 group and this is a hydrogen and this is some CH3, and let's suppose the hydrogen and a phenyl there. Okay, so this is not stable carbocation. So it means rearrange we can go, right? So question be like, should I to go with methyl? Should I would go with the phenyl or should I go with the hydrogen there? Remember the pinacol rearrangement rule? So the same here. Like which one we are going to follow? Okay, so now out of all the three cases, I have to go with the hydrogen. Why? Because the shifts at HP and then R is there. So means in this case, how it is going to rearrange it? That is a 1-2 hydride shift. Right, Arul? So the same migratory aptitude. Basically what is happening. Let me just quickly give you a brief like mechanism part. So if you remember that tetrahedral kind of intermediate, we are ended with this thing. Okay, like you are having some R des and then this O. O is connected with the group. So this R simply switching the position from there to there. It means we are migrating. We are migrating the carbon. Like for example, this is a O negative, be like it's connected with some extra group, and then this is a some R des and there is some R is there. So like so that we have to go with this or this. So it's like the previous one carbocation and we are rearranging the thing. Same here. Now oxygen negative and see we are rearranging the R negative or R is there. So like it's a kind of rearrangement only here. Is this point clear? What is the meaning of migratory aptitude? Means if you have to undergo the rearrangement, so which one is going to migrate first? Like the tendency to migrate is the migratory aptitude. Okay, Arul? I hope it's clear now. Okay, then, so let's just back what we're discussing. Yes, please answer this question. Okay, some options for you, like what will be the final answer? Oh, oh, sorry. 6, 6. Okay, 7 member. Okay, you can count the number be like this, okay, because sometimes we are not able to write all the carbon properly. Okay, the second one. Yes, please. A is the correct answer or B is the correct answer? Wait, I have to remove the number and all this thing. Yes, please. Which one is the final answer for this question? And this is the Baeyer-Villiger oxidation. If you are able to solve the question, it means you are able to understand it. Okay, wait. I will change the position. I hope it's visible now. Yes, please. A is the correct answer or B is the correct answer? Yes, come on, everyone. A is the correct or B is the correct? Like topic wise, it's easy. But mechanism wise, you can say it's A. Okay, rule. Yes, please, everyone reported your answer so that I can check whether you are getting the concept or not. Otherwise, I'm going to explain one more time. Yes, please. I guess no, right? So we have to proceed. Okay, Neharika, B. So let's check A is the correct answer, B is the correct answer. Okay, so yeah. So look at this. In this case, if you to observe this side, here carbon is connected. Carbon. So which kind of carbon this is? It's a secondary carbon because it's combined with carbon and one more carbon, secondary carbon, right? Now let's talk about this carbon. Okay, so this carbon is a tertiary carbon. See this carbon connected with carbon, carbon and a carbon, tertiary carbon. We just discussed the order is there, that is tertiary is going to react first, then secondary, and then phenyl, and then primary. We just discussed, right? So should I have to go with the option A or option B there? Yes, please. At least let me know now. So tertiary or secondary? Tertiary side. Okay. So it means we are going to add the oxygen toward the CO3 side. It means option A is the correct answer, not the B. Okay, Niharika? And everyone, that which one is the correct answer? This is how you can decide. Let's solve one more question. Okay? Okay then. Okay, I know it's a bicycle compound, but try to understand. Okay. Yes, please. Okay, wait. You know, the question. It's option number A, okay? 1, 1, 2, 3, 4. Okay. Yes, please. A is correct or B is correct? So, Dashika, just watch the recording class, okay? Otherwise, any problem, let me know. I already told you like today's class is going to be little bit, okay? It's not hard, but you know the different concept we are dealing today in today's class. So, test part is not a new, but yeah, Baeyer-Villiger is important and new for you, complete new. Yes, please. A is the correct answer or B is the correct answer? Okay, anyway, I have to explain. So look at this. If you're observing this carbon, okay, this carbon. So it's connected with one carbon, two carbon, three carbon, and a four carbon, right? So ma'am, degree wise, that carbon is going to be the correct, right? Degree wise, this is the case. Okay, not an issue. And like in this case, if you're observing this carbon, it's a primary one carbon and a two carbon and three carbon. So it's a tertiary carbon. So listen, that I know maybe you're going to say, ma'am, here you're having a 3,3 methyl group. So degree wise, this carbon is more visible there. But no, it can't be. Okay, just observe that it's a really very bulky group. Do you know how it does look like? It's an open book like structure. Okay, wait, I will explain how. Just look at this. This is a half open book structure like this. Like this. Okay, now I'm asking a normal question for you. That if I'm attacking, so I have to attack from here or here. Like A is the more visible or B is the more visible according to you. Okay, Arul. Yes, please. Down or up? Which one? Okay, if I want less endurance, of course from the top. No, 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 Niharika. Listen, you know this is how the book, it's like tilted. Okay, let's suppose this is a kind of this structure. Then obviously that from the above no hindrance, but below there's a so much hindrance there. Okay, do you know how the hydrogen connected like this? So hindrance. from the bottom. So that's why we are observing the attack from the top side. Okay, so in this case, means what is the problem? That it's an open book structure and it's a very huge bulky group, bulkiness and a crowd is there. So yeah, we are right sometime like degree wise, but in this case, the correct answer still the option will be there because it's a bridge head position and it can't be possible for this to move that much easily, to migrate that much easily. So you can say it's a kind of exception. I hope you are getting my point that why the option B is the correct here. Okay, so that's it. This is all for the case. The correct answer is going to be the option number B, not the option number A, because hindrance is also the important part. Okay, Niharika and everyone, very good, Arul. You're right. More load on bicyclic corner, not stable, right, ma'am? Yeah, you're right. Okay, load you can say, or like you can say migration is not possible. You know actually how it's look like. You know how actually it's look like. It's a let's see the number of carbon. Like 1, 2, 3, 4, and 5. So it's a basically a 5-member ring. Okay, and let's count this side. So again, that is 1, 2, it's a 6-member ring. 1, okay, I'm erasing this side now. I'm just explaining how actually how, what is it? So it's a 1, 2, and 3, and then 4, and then a 5. So like, this is how. Okay, see this. And actually we are moving this thing. Okay, it's very closed thing. And now some bulky group is also connected. This will be like, first of all, we are already very much connected. We are head, and you are basically migrating us, and with the so much number of carbons, so definitely the hindrance have to be there. Okay. So I hope this point is clear for everyone. It's not planar structure. Planar is sorted, but in this case, it is not planar. This kind of question asked in advance, it's not for the part of the main. Okay, so don't worry about these kind of structures. Okay, I know the first problem with the student when this structure in come in exam, so definitely they are going to left this question. But it's easy. Try to understand, and I hope the question is clear and the Baeyer-Villiger oxidation is clear for you. Okay, now yes, please try to answer this question. Okay, this is HW for you. Okay, in the next class, I am going to answer the question. And last question, and HW for you. Okay, option number one. This is the correct answer. Or option number B. Okay, maybe it is not visible. Wait. Okay, this is option number one. B. This is the question number one. Okay, HW question. A is correct or B is correct? You have to identify this. Okay. No, Aruli. Okay, I guess tomorrow, day after tomorrow, and then okay, next class will be on next Monday. Okay, because I guess you are busy with the festival, and I guess no one is going to attend the classes. Okay, enjoy your holiday and please revise the thing properly. Next question, please. Okay, in this case, option number A, and please, it's a Baeyer-Villiger oxidation. I guess I missed this here. Baeyer-Villiger. Okay, just solve this here only. A is correct or B is correct according to you? This last one. Come. Yes, please. Last question. Solve this. A is correct or B is correct? Sorry, sorry. I had to change. It's going to be the hydrogen. Okay, yes, please. Now answer the question. A is correct or B is correct? The previous one is the HW and then answer this. Yes, please. Which one is the correct answer here? A or B? If you are smart enough, you are able to answer the question. You know what is the first topic? What is it? Aldehyde. So if you are having aldehyde, what is happening? Acid, right? So yeah, you are right. I just want to check like actually you know that thing or not. Yeah, B is the correct. But do you know why B is the correct here? Because we just discussed migration. That H come and then phenyl. So see, definitely the oxygen is going to add toward the hydrogen side. Okay. So is this point clear for everyone? That why in aldehyde we are end up with the acid, not the ester like the ketone. Okay. That's it. This is all from my side. Now your turn. Any problem, any doubt, please ask. Okay. And yes, thank you so much for joining the class, everyone. And thank you so much for your time. Happy Diwali all. And enjoy your festival. Revise the thing properly. Don't waste your time too much. Okay? That's it. Because you know what notification or NT already released the paper date and everything. So this time is very, very crucial for you. I will repeat one more time, Arul. Look at this. If you are having a kind of aldehyde, okay? So my question for you that A is the correct answer or B is the correct answer. Okay, Arul? So it's be like this is a CO group. So same point that should I to add the oxygen toward the hydrogen side or the phenyl side. So migratory aptitude said hydrogen, then tertiary, then secondary, and then phenyl. So H has a maximum migratory aptitude. It means oxygen is going to add toward the hydrogen side. At this point we already covered that aldehyde give the acid there. Okay, is this point clear now? Thank you so much, Niharika. Thank you so much. Yes, please, Arul. Is this point clear? That why acid form when we are having aldehyde? Because hydrogen has a maximum migratory aptitude. Okay, Arul. So that's it. I hope it's okay now. So thank you then. Let's end.